Okay, hello everyone. My name is Simon Monk, and the title of this presentation is Web Interfaces to Control Hardware on the BeagleBone Black. So for those of you who haven't had a chance to have a look at the BeagleBone Black, then lurking underneath this electronics here is a BeagleBone Black. One of these. It's a single board Linux computer. And what I'm going to look at today is how you can control devices like this light bulb that's attached to this over a web interface using the BeagleBone Black. Okay, so as I said, my name is Simon Monk. I'm an author on the topic of open source hardware. So I currently have a book on programming the BeagleBone Black using BoneScript, and that's BoneScript that I'm going to be covering in this session. I also have books on Raspberry Pi, Arduino, and a few general electronic texts. If anybody wants to come and find me, I'm actually on the Tab book stand, which is about 2 blocks back over that way towards the main door. We've got a whole range of Tab books that you can go and have a look at. So, the BeagleBone Black, as I was saying, it's a single board Linux computer. There are 2 revisions that are currently widely out and available, Revision A and Revision B. Revision B is, if you like, the one that most people are probably going to have. And they both run a version of Linux, a distribution of Linux called Armstrong, which fits into 2 gigabytes and is fairly sort of small and concise. BeagleBoard are in the process of moving over to use Debian. So if you're getting newer boards like the Revision C board, that will have 4 gigabytes of built-in flash memory, big enough to be able to take on Debian and have Debian installed on there. Irrespective of which flavor of Linux you have on there, these examples should work just fine with them. So the BeagleBone is very much like a Raspberry Pi that I'm sure a lot of you have seen round and about today, except that it has one of the features it has is that you can boot it up from its own built-in flash memory. You don't necessarily have to plug an SD card into it. You can plug an SD card into it and have it boot up from it, and you can also use the SD card to update the Linux distribution that's running on the BeagleBone. I'm going to use a few examples of code in this. Well, there's going to be quite a lot of examples of code in this presentation. You can go and get that code from my GitHub repository. If you go to github.com/SimonMonk, that's probably the only bit you need to remember. If you have a look in there, you'll find a number of different repositories that accompany my books and also include this example code that we'll find here. This example code is all actually taken from our book, Programming the BeagleBone Black. So what do we mean by having a web interface to the BeagleBone Black, and why should we want one? Well, this is the sort of scenario you might have. So what we've got here is a BeagleBone Black, and we've got an LED attached to some solderless breadboard. And then you can see here we've also got a mobile phone that is connected over Wi-Fi to the same network as the BeagleBone Black, and we're running a browser on that phone, and that browser is connected to a web server that's actually running on the BeagleBone Black. So the BeagleBone Black is running a web server that we can interact with from a browser anywhere on our network. So we could connect to it from a laptop, from an iPad, or from a mobile phone. This case, it's just turning an LED on or off, but we could make it slightly more interesting, as I have in this example, where we're actually turning a proper old-fashioned incandescent light bulb of the type that you'd used to find in the tail lights of cars. We'll turn that on and off using the BeagleBone Black. So to be able to do that, we have to use a transistor and a couple of other little components to be able to supply enough current to be able to control the light. Accompanying the electronics, we'll also have a web interface. So we're going to be able to go to a browser, connect to a particular URL on our local network that's being served by the BeagleBone Black underneath there, and we'll have two buttons on there, on and off, and we click on, it's going to turn the light on, and we click on off, and it should be able to turn the light off for us. So let's actually, I'm going to try and do that now with a live demonstration, which is always risky. But before actually I switch and show you the hardware, what I'm going to do is go over to the browser and show you how you program a BeagleBone Black. So what we have here is a web-based integrated development environment. So on the left-hand side we have a list of files, and these are files that are on the BeagleBone Black. And then if we open up one of those files, so we're going to open up LED on-off server. So this is the server code that's going to allow us to control this light bulb. So there's a program that will do this, and I'll go through the code a bit later on. I think it's more fun to see it working and then describe how it works. So what we'll do is we'll run that program, and what that's actually doing is starting the web server running on the BeagleBone Black. So what we need to do now is go over here and start a new tab and connect up to the BeagleBone Black again, but up to a different port, to port 8080, which is the port that I've got the web server running on there. So we'll hit that and let it hopefully load up the page. You may notice that the URL here in the address bar, 192.168.1.21, is connecting, is not your typical sort of local network address. What's actually going on here is that the BeagleBone Black has a USB to network bridge. So, oh sorry, I haven't got the right URL there. So it has this network bridge that allows the BeagleBone Black to appear to be on a network connected to your computer, just using the USB connection. Okay, I have the wrong. Jason is helpfully signaling the right. Thank you, Jason. Okay, so we'll get this web interface loading up now. Okay, so we've got a web interface served from the BeagleBone Black. I'm going to attach the battery pack that supplies power for the light bulb. And then let's switch over to the, in a minute I'm going to click on the on button, but let's give you a view of the desktop. Okay, so click on the on button on the web interface, and there the light comes on. Click on the off button, and the light goes off. So although we're using a light bulb, you could use something more sophisticated. You could have a relay there that's controlling something of greater power, or even a door latch or something like that. So, and then you can make your web interface as complicated as you like. So you could be, for example, entering passwords to then allow the door latch to be released to let you into your house, for example, if you had a home automation system. All sorts of possibilities there once you can get access to the GPIO pins and actually control things, turn things on and off. Right, let's go back to the presentation. Okay, so how does this work? Because it seems a bit sort of magic, really, in a way. We're somehow connecting to a web server, but how is the communication happening when we click on the on-off buttons? We need to know how all that kind of thing works. So what we have is if we start at the browser end, we've got a browser that's displaying a page that's been served from the BeagleBone. So if you look up at the top of the diagram, in the top right, we've got this page.html, and this is kind of the static content of the page that's going to be sent to the browser. And then we have a little web server, regular web server, running on the BeagleBone Black that will stream that page back, serve that page back to whatever browser requests the page. Once that page is up and loaded in the browser, what we then want to be able to do is arrange that when we click on the on button or click on the off button, that sends a socket-based communication to the BeagleBone, which means we don't have to reload the page to get a change in state. We can actually have the on button trigger some JavaScript on the web page that then does a socket communication to the BeagleBone and tells the BeagleBone to turn on the light. Okay, so we've almost got two pieces of server code coexisting on the BeagleBone Black. We've got one that just serves the static page, which is going to be displayed in the browser, and we've got one that's going to handle the requests that come over from the JavaScript on that web page. So it takes a bit of getting your head around, but the best way is to kind of fire up an example and just play with it, and then you can expand it to do what you need it to do. So if this is for, if we look at the HTML for the page that's being served, and as I said, don't worry too much if you can't capture all the details of this page. It's all available on my GitHub site, so you can download it and play with it at your leisure. So the first thing we do is import this socket.io library that allows us to do the socket-based communication between the JavaScript running in the browser and the BeagleBone itself. And then we've got a couple of JavaScript functions. Remember, these are functions that are JavaScript and are going to run on the browser. These aren't running on the BeagleBone, these are running on the browser here. So we have a function called LED on, and when that gets run, it sends a message using this socket.emit. That'll send a message to the server counterpart living on the BeagleBone Black that it needs to do something. And what it's saying is what it needs to do is a digital write, and then we have some formatted text in JSON format that says what we actually want to do is write a specific pin P914, which is the name of the pin that's connected to the transistor on here, and we want to write it a value 1, meaning turn it on. In other words, turn the light on. So when that message gets to the other side and gets decoded by the BeagleBone server's counterpart, it'll turn on that pin and turn on the light. We have almost identical function here called LED off that's just going to fairly obviously turn the light back off again. The actual HTML body that's displayed our on and off buttons and a little title is here, so there's nothing particularly special here other than there's two hyperlinks that have an on-click attribute of LED on, which calls the bit of JavaScript we were just explaining, or calls LED off whether you click on or off on them. So that's all stuff that's running on the browser itself. We now need to turn our attention to what's actually happening on the BeagleBone. So on the BeagleBone, if we look at the server side of that, there are some libraries that we need to import that we're going to need to work for this to work. So there's the socket.io stuff that allows the communication. There's the FS is the file system, because we need to be able to read the file that we're going to serve back to the browser. And then BoneScript is the library that allows you to control the I/O pins on the BeagleBone Black. And then finally we have another variable that's really a constant for the page that's going to be saved. So it's just the address of the page that's going to appear on the web browser. And then we tell the app to start listening on ports 8080. Okay, so we have a function in here called handler, and this function here will be the same for every kind of application you write like this, where you want to control something over BeagleBone Black. It will just serve up the page. It'll serve up the static HTML that has to appear on the browser. So all that's really going on here is some error checking wrapped around reading a file and streaming it back to the browser. Okay. So it writes a response of 200, and then it writes the data, where data is what it's read from the file. Okay, so then we have some more handler type functions living on the server. We have an onConnect function, which is going to get called whenever a connection is established between the browser and the server code living on the BeagleBone Black. And what that does is it register a handler there. So it registers a handler against the lane digital write. So if you remember in the JavaScript function we had over on the browser, if we just step back for a bit, we had this digital write token to say this is the kind of message we're sending. So back over on the server page, we've got that same digital write there. So every time the server receives this digital write message, it knows it's got to call the function handle digital write. And here's the function handle digital write. It parses the JSON string that tells it which pin number and which value and what value to set that pin number to. This console line is just a bit of trace, a little bit of debugging trace so we can see what's going on. The next thing it does is set the pin mode for that particular pin to be an output, and then finally it does a digital write to that pin of the value that was specified in the little JSON message string that came over. Okay, so that is actually all there is to that code. It sounds horrendously complicated, but if you take it apart and you run it up as an example and just try it out, you'll find it starts to make sense. It's fairly straightforward. So let's have another look at another example, because of course you're not restricted to just turning things off and on with the BeagleBone Black. You've got pulse width modulation control, which will allow you to control the power going to things. So we can control the power going to this light bulb by varying the length of pulses, which happens automatically for you if you use this kind of analog write type feature. So let's have a go at that. So again, we'll go to the integrated development environment for the BeagleBone Black, which is running in this tab, and we'll close these programs down, and we'll load up the program. If I can find the right program. PWM server.javascript, there we go. Okay, so we'll get this program running, and then let's stop the old program first, run this program. We'll switch over to the user interface, and now if we reload that page, we should find that instead of having the on-off buttons, we get a slider that we can then use to control the power to the LED. So I'm just going to, it's a shame I can't show you both at once really, but I'm going to switch over to the board, and then I'm going to whiz the slider up to maximum, whiz the slider back to halfway, whiz the slider right back down to nothing. So now we've got a dimmer. So you can imagine if you had a whole array of 3 high brightness RGB LEDs, then you could make a nice sort of color fader, a web interface to a color fader or something like that. Okay, so let's switch back to the presentation. Okay, so looking at the code for this, we've got, if you look into the header of the HTML, this is back over on the browser again. You see that we've now got a function in here called update slider that takes a value. Oh, sorry about that. Update slider that takes a value. And then we've got, rather similar to how we turned an LED on or LED off, we're sending another message. And this time we're sending a message called analog write to the BeagleBone Black. And we're giving it the pin number to write to and a value. And this value, we're scaling it so that it's a value between 0 and 1, because the slider is going to give us a value between 0 and 100. So we just divide it by 100 to get a value in the right range. So if we look at the user interface part of the web page, we've got the usual sort of, we've got an input type called range, which is what implements the slider on the HTML on the web page. And it has a range of 0 to 100 and a step of 1, so as we move the slider about, it'll change value. And we have this onChange handler, with onChange attributes of this input, this range input tag, which will automatically call update slider with the current slider value every time the slider's position is moved. Okay, so that will automatically update it. If we switch over and have a look at how the server code of it works, much of it is the same as for the digital writes. So we still have to register an analog. Now we register an analog write instead of a digital write. And whenever we receive that message from the browser, we're going to call handle analog write function just below here. So again, this parses the JSON message to find out what the pin and the value are, and then it just does an analog write of to the particular pin, the particular value it should have. Okay, the next example, I don't actually have a physical example to make up and show you, but I'll just talk through it. And this is doing analog reads, because as well as outputs on the BeagleBone Black, you've obviously got inputs. So you've got digital inputs, which are switches and on-off type values. But you can also read analog values. One of the differences between the BeagleBone Black and the Raspberry Pi is that the BeagleBone Black has analog inputs, so you can measure voltages on the BeagleBone Black. So an example might be to use one of these very common temperature sensors. It's a sensor chip called a TMP36, and it has just 3 pins. It has a ground pin that you connect to ground on the BeagleBone Black, which is shown by the blue wire. It has a 5-volt pin, or I think it'll also work for 3.3 volts, that is connected to this brown lead at the top. And then its middle pin is just a voltage output that is proportional to the temperature. And there's a little sum you do on the voltage that will tell you the temperature that the sensor has. Okay. So as I said, the sensor is called a TMP36 chip. They're very widely available. So how do we do an analog read? How do we provide a web interface for an analog read? Well, the page serving part is going to be exactly the same as the 2 examples I've just given. We're just going to serve back a static text page, and then we're going to the browser is going to send a message to the server saying, I want you to monitor a particular pin, a pin of interest. Because what we want is we don't want to have to refresh the page every time we want to see if the temperature's changed. We want the server to be telling the web page that the temperature has changed and updating the display automatically in the JavaScript on the page. Okay, so the way we do that is that the browser tells the server to monitor a particular pin, or multiple pins if we've got multiple things we want to display. And then the server sends a socket message back to the browser every time the value on that analog pin changes. So let's have a look on this makes the code a little bit more complicated on the browser. So if we look in this script section, we'll see that we're defining the pin that we want to use, and then we've got socket on pin update. We're going to call handle pin update. So every time we get a message from the server saying the voltage on a pin has changed, it's going to call this function here, handle pin update, and that will read the value, the new value of the analog pin, and then calculate the temperature from it using this maths here. And then we use jQuery, which is a JavaScript library which allows you to manipulate what's already displayed on the page to actually change the number in situ, so that it'll update what's displayed on there. Okay. And then the HTML that actually does the displaying is very simple. We just have a label, but then we have another heading 2 that's actually going to contain the text of the temperature. And and it'll change dynamically as the temperature changes on the thing. So this has to have an ID, so it has an ID of temp, which has to match back with with this value here. So that's how you change that piece of HTML within the web page that's already being displayed. Okay, so the server code is fairly similar to the other server code we looked at. We have these series of handlers so that when we handle a request to monitor a particular pin, we actually use an array to keep track of that's a pin we're interested in. Okay, so that this is only so that it allows you to have multiple pins that you can monitor. So it does that simply by putting a value into the data structure, into the object data structure. I'm conscious that I'm running short of time here, so I'll try and speed this up. So then we have a function called check inputs that's going to be run on an interval every 50 milliseconds. And what it does is it checks for each of the entries in that array that I mentioned earlier for the pins that we've registered an interest in, and it takes an analog reading on that pin, and it sees if it's changed from the previous value. And if it's different from the previous value, then it calls this chunk of code here that sends a message called pin update back to the browser, and that's when the browser gets to change the HTML and display the new value of temperature. So all a little complicated. But so one of the questions that arises really is, we're having code in the browser that's saying which pins to use on the server, and is this always the right pace for the logic? It may be that under some circumstances it's better to have the server decide which pins it's going to use and things. So you can move that code over to the server, and in some cases I think it probably is better. Particularly if you have a situation something like this, where you might have a timer where you've got an input field where you say how many seconds you want the light to go on, and then you have a start and a cancel button. It's probably better to send messages that are more, if you like, start the timer with a 4:10 seconds, or cancel the timer and kill it dead now. Those are probably better messages to send to the BeagleBone to interpret it in its own way, because you could potentially have lots of browsers open on this particular server, so you don't necessarily want the browser deciding which pins are doing what when. Okay, and I'm going to have to skip over this slide on the timer server, but that gives you the idea that it's receiving messages of the sort start timer and cancel timer, rather than turn pin P9 18 on or off. So in summary, this is one pattern for doing web interfaces, and there are other patterns, and check out the BeagleBoard website for other approaches to making web interfaces to control GPIO pins and to control hardware in general. Okay. So, further information, have a look at the beagleboard.org website. There's lots of good examples on there, plenty of useful material. And as I said before, check out my book, Programming the BeagleBone Black. And for all the code examples used in this session, you'll find them all on GitHub in my prog_BBB repository, which accompanies the book. Okay, that's it, I think. Thank you very much. Thanks.